Hello, my name is Rosemary Dixon, and today we're going to be talking about the science behind why our glasses fog up while we're wearing masks. As you've probably experienced, especially if you wear glasses during this pandemic. So to start off with, we first got to talk about the concepts behind this idea, or the science behind it. The concepts that I'm going to be talking about are convection, which is how the mechanism for how cold air replaces warm air, pretty much, and the reason why it happens. So for convection, you can commonly think of it as cold air is actually denser than warm air. So what happens is warm air rises, and then the colder, denser air actually replaces it. So, for example, when we're outside and it's like really, really cold out, you can see our breath, right? Well, the breath in our mouth is actually warmer than the outside. And this actually leads, and so you can see it kind of rising. Well, this actually leads into condensation, which is when the gas turns into a liquid. For an example of this phenomenon, it's when you have a cold drink, like maybe say you have ice and it's in a glass container, and you see like what looks to be water on the outside, or liquid. That is an example of condensation. And that cloud of fog, well, the cloud of air that is shown in the cold air, that's actually the condensation of the gas being turned into a liquid form. And then another concept that's really important is humidity. Now, humidity gets confused for a lot of things, but to put it in simple terms, humidity is the amount of water vapor in the air. And the one thing we need to remember most importantly behind humidity is that cold air cannot hold as much water vapor as warm air. So picture this in your mind. When you're in cold air, it is like most likely 100% humidity, because it can't hold as much water vapor in the air. While warmer air, it can hold a lot more. So those are the concepts behind this phenomenon. And so I observed this event, or this phenomenon, at my own home. And I also did it outside when I was on my way to work one day. And this happened in November, near the end of November, because as I'm recording this, it is actually in December. And the objects that I observed was my glasses and my mask. And the subject was myself. So I actually tried these things in multiple different ways with different masks to see if it would change the result. So on the left of here, we see me, I'm outside. Well, it was cold and it was actually snowing on that day. I don't know if you see the snow there, you probably don't, but it is like extremely cold out there. And you see my glasses, they're fogged up and I'm wearing a mask. Well, on the right is me in my own home. And I'm wearing my glasses again. I'm wearing the same mask as I did in the other picture. But do you notice my glasses that even though they're fogged up, they're not as worse fogged up as in the left? Well, that's because of the fact that it was cold outside, so there was more humidity outside than there was inside my own home. And the mask, it kind of collects all the hot air so it doesn't go out. It's stuck in such an area, And so it tries to escape. The warm air from my breath tries to escape. And if there's like any gaps, it'll come up. And so it hits my glasses, and they are colder than my breath. And so it actually starts fogging up, and condensation starts forming on my glasses, which is what the fogginess is. So I did a little test to see if like it was just with all masks or just this one. I noticed that the more the tighter the mask was on my face, the less my glasses fogged up. And I also noticed that with temperature-wise was also important. The colder it was outside, the more my glasses fogged up than if it was warmer. So I don't know if it'll do right now, but I'm going to put this mask on, the one I have wearing in the pictures, and I'm going to try to show you a live demonstration of it. So you see how my glasses fogged up? There's a lot of warm air in my mask right now. And as I'm talking, it's releasing more and more of that hot air, and it's actually escaping from here, because if you look at the mask, there's like a little opening at the top of my nose. And so the warm air from my breath is rising up and touching my colder glasses, and it's actually fogging my glasses up. So, as I explained, the hot air of our breath rises, and when it meets the cool lens of my glasses, condensation is actually happening, because of warm air is meaning colder, humid air. You see, it doesn't happen just our glasses. You see it like, if you're moving, even with a mask, you're going outside, you spend time in cold air, right? And then you go into a warm area. Notice how your glasses immediately start fogging up? This is another example of exactly what's happening with our mask. Except it's happening more constantly, because we constantly have that hot air from our breath, or even from when we are breathing through our nose. It's constantly rising up, while when you're going in a from a cold room to a hot room, it happens instantaneously. But as the temperature stabilizes or reaches equilibrium, it actually goes away. So once your lens actually starts like warming up from the warm air, you'll notice the fogginess starts going away. The same thing happens with you're wearing a mask. As soon as the warm air, like when I'm talking, or if I'm not talking at all, there's a lot less fog because it's not rising up. So the convection's in action is because it's rising, and the water vapor in the air, or the humidity, actually turns into condensation. You can also see this in the mornings. It happens usually during the coldest time of the day. You can see in the mornings. Sometimes you'll see dew on the grass, usually in like the spring or early in the morning. This is an example of like condensation or dew point temperature. And so, and as I explained previous, hot air will contain more water vapor than cold air. And so when it is released, it is meaning more humid air, causing fogging or cloud, or like when you're outside, it looks like a cloud. And so, and the reason why the connection to this course is, we talked about convection in chapter 11, which was more about the atmosphere, like I think it was an atmospheric heating, and it is like, convection is something that we see all the time, but we really don't think about. While condensation, we see it, and we talked about it over like the water cycle, and weather, and like how, like clouds and stuff like that. We talked about it in chapter 3. We see it on our glasses with the liquid on the outside. We see it with when our glasses fog up. And we see it as dew. And then humidity we talked about in chapter 12 when we were also kind of talking about weather and clouds and stuff. So I came up with this idea because I was thinking about what I wanted to do, and I wanted to do something with heat. And I automatically thinking about was when I walked outside one time when it was really cold out, I could see my breath, and I was like, I wonder why that happens. And so after talking out with somebody or my teacher, it kind of helped me decide to do why our glasses fog, because it's something that is happening right now, especially with this pandemic. And honestly, this entire class has helped me better understand the concept of what I'm seeing. And I'm looking at my surroundings, I'm like thinking about the science behind it. So this is finished with my final project. But I want to thank you, Dr. Cunnings, for teaching me about Earth and space science. I really enjoyed your class, and you have changed my mind about what I'm seeing outside. Like, I'm looking outside and I'm thinking about the science behind it. So I just want to thank you.